Welcome to Chapter 8 of the Raymarching Shader in Unity tutorial by PeerPlay. In the previous part, we've seen how shadows add realism and depth to the 3D scene. We will continue by adding more shading tricks to beautify the results. In this part, I will teach you how to add ambient occlusion to the Raymarching Shader. In computer graphics, ambient occlusion is a shading technique used to calculate how exposed each point of a scene is to ambient lighting. Points that are surrounded by objects would gain less ambient light than the points on the outside of an object. Let's have a look at the results of the ambient occlusion on this scene. At this point, I am only returning the ambient occlusion calculated. We multiply our shading results by the output value of the ambient occlusion. The outside of this object won't be influenced by the ambient occlusion. The inside of the sphere has medium ambient occlusion, and the strongest values are found at the ground where there is a narrow ridge. There are many ways to calculate ambient occlusion, and I will show you a technique that gives us 3 values to play with. First of all, the step size, which is the maximum distance from each point that is affected. Secondly, the amount of iterations. For each iteration we have to call the distance field again. And lastly, the overall intensity of the ambient occlusion values applied. If you find the contents of my tutorials helpful, consider supporting me at Patreon. In doing so, you enable me to continue creating these for my peers, and you get access to the tutorial source files and exclusive content. Special thanks to Andrew Laboy, Devin the Dude, Derek Fegter, Patrick Nugent and Esperdyne. We'll continue where we left off in the previous part. Before we create the ambient occlusion, I'd like to add a few more public parameters on the max iterations of the Raymarching and its accuracy. Let's open up the Raymarch shader. In our Raymarching function, we set the max iteration to a constant integer. This value specifies the accuracy of the returned distance field. I want to be able to set both these parameters in the inspector. Let's scroll to the top and add these parameters to the shader. So underneath here, I'm going to type a uniform integer, and we're going to call the integer max iterations. And we'll also add a uniform float, and we'll call this accuracy. Let's now implement these. So in the Raymarching, we're going to set the max iteration to become the max iterations, and the accuracy we'll put in here. Now let's save the shader and go to the Raymarch camera. And we're going to write them in here. So we've got a public integer, and we'll call this max iterations. And we also need a float, so public float, and we'll call this accuracy. Now let's also set a range for these parameters. So I'm going to type range for the max iterations, and that is between 1 and 300. And the range for the accuracy is going to be between 0.1f to 0.001f. Now we just need to send these to the shader, so let's go down, and underneath the max distance, let's create a new line for a float. Now this float is going to be the accuracy, and we need to set the integer for the max iterations. So Raymarch material.setInteger. We're gonna set it to max iterations. There we go. Now let's save this script and go back to Unity. The higher you set the iteration amount, the heavier the shader will be. You can find a trade-off between the accuracy and the iterations so that you don't see any white spots. With this in place, let's now add the ambient occlusion to the shader. There's one more thing to change, and that is to define the main color inside of the shading function. So let's copy this, remove it from here, and inside of the shading we're going to apply it. So we'll say a float3 called color is the main color.rgb. So we'll call this the diffuse color. Now I made a mistake in the directional line where we declare a float and we multiply a color. So this should be a float3, And let's call this actually light. Now at the top we'll declare a float tree and we'll call that a result. And we'll set the result to become the color multiplied by the light multiplied by shadow. Let's now add a new function for the ambient occlusion. So let's create a float and we'll call this Ambient Occlusion. And this has as an input a float 3 position and a float 3 for the normal. Let's call this function in the shading. So we'll say Ambient Occlusion. And we'll create a float and we'll call this AO. And we'll call here the Ambient Occlusion. And we'll input a P and N. And let's multiply the result by the ambient occlusion. Now how will the ambient occlusion work? We have a current position and a normal direction. From our position we set a step distance to move forward along the normal direction. We will check the return distance field and based on how near another surface is to the current position, we add the resulting value to the ambient occlusion returned. We'll start with the step size, so we'll create a float, we'll call this step, and that is going to be some amount. Now I want this to become a public parameter, so let's create a uniform float. And we'll call this the ambient occlusion step size. And let's use this float on the step float. Now we also need to keep track of the total amount of ambient occlusion returned, so I'm going to create a float and we'll call this AO, and we'll set this to 0.0. And let's create another float and we'll call this float dist for distance. And as we want to be able to do multiple iterations, the dist float will be the step size multiplied by the current iteration. To do multiple iterations, we're going to create a for loop. So for int I for its iteration is 1. If I is less than or equal to the amount of iterations that we want to do, which will be another public parameter, so let's add that. So uniform integer, and we'll call this ambient occlusion iterations. Now let's use this one inside of the for loop equation, and then we're going to do I++. Now let's set the dist, so dist will be the step multiplied by I. Now we need to set the ambient occlusion value, so we'll say AO plus is, and we need to call upon the distance field, so we'll say distance field, and we want to check its current position plus the normal direction multiplied by dist. Now I will explain what's happening here in a moment, but we need to subtract from distance the distance field equation. And we're going to put this in parentheses, and we're going to divide that result by distance again. Now if the result of this distance field is inside a surface, this will result in a minus value. We want this value to be at least 0, so we'll place a max around the equation. So we'll type max, and we'll either get a 0.0 or the result of the distance field. Now we're going to return the 1 minus value of the ambient occlusion. So let's say return, and we'll say 1 minus the ambient occlusion multiplied by the ambient occlusion intensity. So let's create another float, and we'll call this the ambient occlusion intensity, and we'll use that in the equation here. Let me explain this a little bit better with two different examples. So in the first example, let's say that the step size is 1. Now the distance field will check how far that resulting point in space is from the nearest surface. So its current point plus 1 into its normal direction. So if the result of the distance field is 2, then we say 1 minus 2 is minus 1 divided by 1 is minus 1. Then we get the max, and the max will take either 0 or a higher number. And as minus 1 is below 0, the result will be 0. So 1 minus 0 is 1. so there will be no ambient occlusion applied. In another example, the step size could be 0.3. The distance field will return with its sphere tracing 0.12, so it finds an object at a distance of 0.12. So 0.3 minus 0.12 is 0.18. Divided by 0.3 again is 0.054. So there will be a little bit of ambient occlusion applied, because we eventually multiply the results of our shading by the ambient occlusion, and as the result is 0.946, this will mean that the result will be a little bit darker. So let's now save the shader and implement these three parameters in the Raymarch camera. And let's add a new header for the ambient occlusion. Let's create a public float and we'll call this the ambient occlusion step size. Public integer and we'll call this iterations. Public float and we'll call this the ambient occlusion intensity. Now let's add a range for all these parameters. To make everything look nice, let's also create a header for the max iteration distance and accuracy. Let's call this setup. Now let's add these three variables to the shader. So we have two floats and an integer, so let me copy these and paste them somewhere. This is going to be the ambient occlusion iterations. This is going to be the ambient occlusion intensity. And the last one is going to be the ambient occlusion step size. Now with that in place, let's save the shader and go back to Unity. Back in Unity, you can now see the ambient occlusion parameters in the inspector. So let me set the step size to 0.2, the iterations to 3, and let's set the intensity to 0.25. With shadows and ambient occlusion combined, the shader looks a lot nicer. Plus, we also fixed the light. With a yellow light on the blue surface, we get a nice green gradient. In the next part, we'll continue by extending the Raymarch shader with reflections. If you found this tutorial helpful, feel free to share this video with your peers. To stay updated to new released parts, subscribe to the channel and turn the notifications on. Happy coding!